In this video, we're going to find the partial fraction decomposition of two rational functions. The first one is negative 4x plus 1 over x minus 2 times x minus 5. We already know how to find the template for these. Let's do the template. This is equal to something over x minus 2 plus something over x minus 5. Again, if they had asked us to find the partial fraction decomposition of a rational function that had not, whose denominator was not already factored, we would have to do the work of factoring the denominator first. But in these examples, it's already been factored for us. So we have to make a decision about what goes in the numerator of this first fraction of x minus 2. The degree of the denominator is 1, leaving a constant in the numerator. In the second fraction, the degree of the denominator, x minus 5, is also 1, so we get another constant in the numerator. Now we need to solve this equation for a and b. This is how we do it. We multiply both sides of this equation by the lowest common denominator, and that will get rid of our fraction. So the lowest common denominator is always going to be this denominator right here. So I'm going to multiply this side of the equation and this side of the equation by x minus 2 times x minus 5 over 1. X minus 2 times x minus 5 over 1. Because this will distribute to each term, I'm going to write it here as well. On the left-hand side, x minus 2 times x minus 5 times negative 4x plus 1 over x minus 2 times x minus 5. What happens is these terms cancel, and we're left with simply negative 4x plus 1 on the left-hand side. On the right-hand side, a over x minus 2 times x minus 2 times x minus 5. The x minus 2's cancel. We're left with a times x minus 5 plus. We have b over x minus 5 times x minus 2 times x minus 5. Right here, the x minus 5's divide out, and we're left with b times x minus 2. Now we need to solve this equation for a and b. On the right-hand side, I'm going to distribute the a, leaving me with ax minus 5a. I'm going to distribute the b. That gives me bx minus 2b. What I'm going to do now is collect the terms together. I'm going to collect the x term. I'm going to get these beside each other. And then the constant terms, minus 5a, minus 2b beside each other. On the left-hand side, I'm going to factor out the x, leaving me with a plus b, and then minus 5a minus 2b. Because the key to solving this equation for a and b is, we're about to do that, we're about to equate coefficients. So on the left-hand side, all this time, I haven't done anything to the left-hand side. I have this. Negative 4x plus 1. Now what I mean by equating coefficients is I'm going to set the coefficient of the x term equal to each other. I'm going to set the coefficient negative 4 equal to the coefficient of the x term on the right hand side, a plus b, giving me this equation, a plus b is equal to negative 4. Then I'm going to equate the constant terms together. 1 is going to be set equal to the constant term on the right hand side, negative 5a minus 2b. So I have negative 5a minus 2b equals to, that was a 1 right there. And now I need to solve this system of equations for a and b. I'm going to use matrix to do this. I'm going to use reduced row echelon method. I just decided to do that. I could use any method. You could use any method that you wanted to use. You just got to solve for a and b. I'm decided to use reduced row echelon method, so I form my augmented matrix. 1, negative 5, 1, negative 2. I'm going to augment this with the solutions, negative 4, 1. I have my calculator right here. I'm going to put this into my calculator right here. Second matrix, I'm going to edit this a. This is going to be 2 by 3. 2 by 3. I'm going to say 1, 1, negative 4, negative 5, negative 2, 1. Now I have my augmented matrix. I'm going to quit. I'm going to go back to second matrix. over to math. I want to go down to reduced row echelon form, which is B. I want to choose matrix A, which is 1, and hit enter. And this is what it gives me. I have decimals. I don't want decimals. I want fractions. I'm going to hit math, enter, enter. And it's going to tell me that the answer here is, this is my after it's solved, I have this. I have 7 over 3 and negative 19 over 3. This is my answer. My A is equal to 7 over 3, and my B is negative 19 over 3. Okay, now the partial fraction decomposition of this negative 4x plus 1 over x minus 2 times x minus 5 is equal to A, which is 7 over 3 over x minus 2, plus B, negative 19 over 3 over x minus 5. An alternate way of writing this answer that is equally as good would be 7 over 3 times x minus 2. If you want to make this negative, if you want to say this is minus a positive 19 over 3 times x minus 5, this is an equivalent answer right here. That would be fine. All right, the second one that we have is this, x minus 7 over x plus 3 squared. This is a repeated factor. The template for this is something over x plus 3 to the first power plus something over x plus 3 to the second power. What goes in the numerator of this expression is a constant term a. Even though this looks like the highest power of this denominator would be a 2 if we squared that, what we base our decision on is the factor that's being repeated. X plus 3 is what's being repeated. That's of degree 1, so we just get a constant term in the numerator. Now to solve this equation, I multiply both sides by the lowest common denominator, which is this right here. X plus 3 squared. On the left-hand side, I multiply it by x plus 3 squared. On the right-hand side, since it distributes, I'm going to write it down 2 times. On the left-hand side, x plus 3 squared times x minus 7 over x plus 3 squared. These will cancel. I'm left with x minus 7. On the right-hand side, a over x plus 3 times x plus 3 squared over 1. One of these factors will cancel, leaving me with a times x plus 3. Plus b over x plus 3 squared times x plus 3 squared over 1. X plus 3 will divide into x plus 3, leaving me with just a b. X minus 7 is equal to ax plus 3a plus b when I distribute my a. Now I'm ready to equate coefficients. The coefficient of the x term on the left is a 1. 1 is equal to the coefficient of the x term on the right, which is a. I found out that a is equal to 1. That was nice. Now I need to set the constant term, negative 7, equal to the constant term on the right-hand side, which is 3a plus b. In this case, I'm simply going to use substitution. I know that a is 1, so I'm going to substitute 1 in for a and solve for b. Negative 7 is equal to 3 plus b. If I subtract 3 from both sides, I'll get that b is equal to negative 10. The final answer is to rewrite x minus 7 over x plus 3 squared into its partial fraction decomposition, which is a, or 1, over x plus 3, plus b, or negative 10, over x plus 3 squared. Again, you could write this as 1 over x plus 3. You could write minus a positive 10 over x plus 3 squared. 2 equally good answers.